Okay, beta ji. Bismillahirrahmanirrahim. What we have discussed, firstly, it was defined what is meant by work done and kinetic energy. We will write the definitions. And then it was asked, here the speed was 22 and the speed changed to 12 at the top. What is the decrease in kinetic energy? So initial kinetic energy minus final kinetic energy. Then it was asked, calculate the gain in gravitational potential energy. The formula is mgh, right? Next part says show that the length of the track from x to y. If you see, it's a circular track and it's 90-degree, means quarter of a circle, and you have to find this length. So the length of the whole circle is 2 pi r and quarter is dividing it by 4. This is what you will get. We all need all these questions for solving this. Now, uh, coming to this part. In the next part, it says, what will be the calculate the resistive average resistive force acting on the carriage. Beta, can you help me? When the object is rising, energy wise, the kinetic energy is decreasing and gravitational potential energy is increasing. But there is something missing in this formula. Can you help me? What is that?
Heat.
Heat. Very well answered. Whenever there will be movement in real life, there is always a resistive force. How? What is the formula for the heat? जी बेटा, loss in kinetic energy plus gain in gravitational potential. The formula for heat is resistive force multiplied by the distance covered along. And that distance covered along will be the length of the track x to y. We have calculated in previous part. The change in kinetic energy we have calculated here. The loss in kinetic energy and gain in kinetic energy we have found here. So you are just, and length of xy was found in previous, which is quarter of a circumference. So now you can find resisting force. What do you think? Can you find? You just have to substitute their values. Now describe the change in direction of linear momentum of carriage that is moved from x to y. So change in direction of linear momentum. How would you linear momentum has a change in direction from x to y. So as initial velocity was towards horizontal towards right, and it's so it means its direction has changed by an angle of 90-degree, right? But this is not the answer. Have we ever heard of there is some formula which is related with change in momentum? Yes. The force is rate of change of momentum. And beta, here the object was moving along a circular path. So when an object is moving on a circular path, the direction of force is always towards the center. And whatever is the direction of force, same, because force and change in momentum are directly proportional. So the direction of change of linear momentum is towards the center of circular path. And is there any name to given to that? Yeah, no name is given. So just saying central circular path is will be sufficient. Determine the magnitude of the change in linear momentum. So beta, we have done that. Change in linear momentum is m into v minus u. First, we need to find v minus u. Here, as the direction are changed, so we will do it vector wise. V minus u can be v plus minus of u. As final will If we arrange v plus minus u according to head to tail rule, the final velocity is vertical 12 and initial was towards right, and that was 22. But minus u will be opposite to that. And according to head to tail rule, according to head to tail rule, this is v, and this will be the resultant of, means addition of v plus minus u, in other words v minus u. So this is v minus u, as it is a right angle triangle. So this v minus u will be a hypotenuse, and which will be equal to the sum of base plus square of base plus square of perpendicular and square root of 4. So this will give you the value of v minus u. Can you please help me finding this? What will be the value of v minus u, beta? This answer to this 144 plus 484. Ji beta. What is the answer to that?
It's
Is it
25.1.
25.1? Looks to be correct. So you multiply whatever you get the answer. The unit is already written there, Newton second. So I hope this question is completed. Beta, can you have a look at it? Is there anything you would like to discuss? Is it all clear?
Yes, sir, clear.
Okay. Any other question of your choice, or we should do the next? What do you think?
Sir, question number 2.
Question number two. This was question number one. The next
Yes, sir,
question,
it was one.
question number two of which is with car. Okay, let us do it here. And the next part of it. Okay, beta ji. Now let us move on and start discussing. Define velocity, rate of change of displacement, or speed in a specific direction. Or a car travels in a straight line up a slope. You can see the car has mass and travel with constant speed. This is most important words. Whenever we say the speed is constant, means the forces are being balanced. The forward force will be equal to the backward force. The car's engine exerts a force of, that's it. It means if the car's engine will be applying a force 2 kilonewton. 2 kilo means 1000,
1000.
right? A resistive force due to friction and oppose the motion. So there is a resistive force will be there, but beta, there will be another force. Do not underestimate. What is that? Whenever anything is on the slope, there is a component of gravity which is acting, getting it downward. That is equal to mg sine theta. This we have done in chapter 1, right?
Yes,
Okay.
sir.
It it may be involved later, not now. I have just shared it with you. Okay, now go on. So a graph is given and the resistive force against speed. And let's see, nothing is asked here. This is the next part. Steadiness means whether the car is in equilibrium as it moves up the slope. Yes, when it is moving up the slope, it is having a constant velocity. So yes, it is in equilibrium. And how do we know that? That it is having a constant velocity means the resultant force, the all the forces acting on are being balanced. The resultant force is zero. So consider the forces that act along, determine the component of the weight that acts down the slope. Isn't that what we were talking about? So consider the forces acting along the slope. Use data from figure to determine the component. So the forward force, the driving force, 2000 Newton, will be equal to the backward friction force. And see, here the speed was 9. When the speed is 9, look from this figure. This tells at that moment the resistive force is zero point 0.4 kilonewton in kilo. Multiplying it with 1000 will make it 400 newton. And the component is also downward. So what is the basic formula? The forward force or the thrust of the engine will be equal to the resistive force plus component of the weight, VC. C for component. Although we know that is mg sin theta, but they have just asked to find. So 400 adding will subtract, and the component is going to be 1600 Newton. Okay, show that the output power of car is this. Beta, look, what is the most important formula for the power? Can you suggest me?
Rate of work.
No. Did you saw the recorded lesson, Hassan? What is the most important formula of the power we discussed?
जी
H.
सर देखा था लेकिन जेन से निकल गया.
Beta, you have to note that down. दोबारा देखें. Most important formula is this. As we want to find the output, power output of the car is this. So what would you say that the power output of the car is? We have to show. What is the velocity? 9. And the for engine. The engine is providing the output power to make the car move. So the power applied by the engine is 2000 Newton and its velocity is 9. You multiply and you get the same answer, 18,000, or you can round it off to, and unit for power is this. The car now travels along a horizontal ground. The output is maintained. The variation of the resistive force is this. Calculate the acceleration of car when it is at speed of this. So acceleration you need to find. What is the most basic formula for acceleration?
V minus U over T.
F is equal to ma. Force whenever the force is involved. So what do you mean by F? F is not force.
Resultant force.
Is the resultant force. Right? So we have a forward, we have power that is 1.810 is to power. And now the speed is 15 meter per second. So we have something to do. From the graph, we can find the 15 meter per second will go like that, and it will give this much. And what do you think it is? It is 0.67. and in kilonewton, so it is going to be 670. So now here we have to find F is resultant force. Never take F is equal to ma. The F is not a simple force, it's resultant force. Forward force minus backward force. So backward force is 670. What is the forward force? So we are given power, it means it must have some relation. So for power, we have P is equal to F into V. The power is 1.8 10 raised to power 4. And the forward force applied by the car, we have to find from here. Velocity is 15. So beta, it will make the answer to be 0.12 multiplied by 10,000. 1200, I guess. Can you please confirm?
Yes, it's 1200.
So 1200 it is. The F is coming from there. This is the forward force. The power is applied by the engine, not the force of the engine. Driving force is this. And the backward force is this much. And the mass is given. Can you tell what is it? 850. So 850. And now you can solve it. First, we have to subtract and then that will be divided. I guess question is completed. Clear? Should we move to the next question?
Yeah.
Any question of your choice, Hassan? Ji
Sir,
beta.
question 3.
You are going in an order.
जी सर ये इनमें प्रॉब्लम आ रही थी मुझे.
Okay. Okay. Question number 3. And here we go. It's next page or next part. Okay, beta ji. Let us move on. So I hope you can see this. A ball of mass 0.030 kg moves along a curved track. Speed is given, mass is given. The speed, we should highlight all the data. The speed of the ball is when it is moving, the height of this. Okay, that is also given there. The ball moves down the track and collides with the vertical ball at B. The ball then rebounds up back the track. It may be assumed that friction is negligible. So this is again no friction. Calculate the change in gravitational potential energy. What is gravitational potential energy? mgh. And what do you mean by h? H is always taken to be the vertical height. So what is the mass? Mass is 0.030. G is 9.81. And what is the height? 0.31. Can you please tell me the answer?
0.09 joules.
0.09 joules. Okay. Is it? Any other number?
12 912.
Okay, 9-1. Now, show that the ball hits the wall at B with the speed. So again, speed, kinetic energy. So what is that? The loss in gravitational potential energy, which we have calculated, will be equal to gain in kinetic energy. And the loss in gravitational potential energy is 0.091 and kinetic energy is half mv square. The m is 0.03 and speed we have to find. Can we calculate? I hope it will be very close to this. Sometimes it's not exactly the same. जी हो जाएगा बेटा. Should we move to the next part?
Yes, sir.
Okay. Change in momentum of the ball due to the collision with the is this. This is change in momentum. And the ball content for the time of this. Determine for the ball colliding with the wall the speed immediately after collision. Beta, the speed after collision will be m is equal to v minus u. Is change in momentum, and we need to find the speed after collision. So final velocity we need. What will be the initial velocity before colliding? And that is this 2.8, right? When it reaches the point B. So this B velocity is going to be the initial velocity. Now we know the change in momentum is 0.096. The mass is 0.030. Now, one thing you will find automatically, the answer of final velocity will be in negative. What does that show? This shows the direction is changed. So it was 2.8. So you divide it and answer will be negative for sure. Clear? So
Yes,
then
sir.
negative shows this. Now magnitude of the force. The force is equal to change in momentum over time. So change in momentum is given and time of contact is also given. What is the change in momentum? Time is 2 millisecond, 20 millisecond. Can you see? So 20 milli means we have to divide it by 1000 or 20 times 0, 10 is to power minus 3. The answer is same, Newton. Say to explain whether the collision is elastic or inelastic. So for elastic collision, the kinetic energy speed should remain the same. For that, now we need this value. Can you please share what is the answer to that? That we, if the velocity remains same, that it is most probably it is going to be inelastic. Can you tell me the answer of V here? First, we will divide it.
V is 6 meters per second.
6 meters per second.
Okay. Oh, and is it in negative?
सर वैसे पॉजिटिव में आ रहा है आंसर.
I'm also getting positive.
Okay. And maybe we had to change the direction of sign if the final immediately after the collision and V minus, so we haven't the change in
सर
momentum.
माइनस वी माइनस यू तो नहीं होगा.
No, no, contact with this. The change in momentum should be negative actually. Why? Because the force is in opposite direction. No? If we keep this as negative, can you now tell what the value V will be? So this is something that was very important in this question. All the values were given. So why the question will be done wrong is this, right? Please now calculate and tell me the answer.
Minus 0.4.
Okay, so that's most likely. So speed is a scalar quantity. You will write it like that, but the velocity final is minus 0.4. Beta, take this as serious question. So, so as the velocities are changed now, kinetic energy is not same. So it is inelastic as kinetic energy is not conserved. because on changing the speed, the kinetic energy is changed now. So initial kinetic energy is not equal to the final kinetic energy. Next part. In practice, frictional effects are significant that actual increase in kinetic energy ball moving from A to B 76, and this is increase in kinetic energy. The length of the track is this. Determine the average frictional force. So again, when anything is going down, then the loss in gravitational potential energy will be equal to gain in kinetic energy. So, beta, please can you tell me which side the heat will be written? Left or right?
Sir,
Heat
right?
always comes towards the side of gain, right? And loss in gravitational potential energy is mgh. So we have calculated, right? So the loss in gravitational potential energy is what we have calculated. The gain in kinetic energy will be uh, here the kinetic energy has not gained. No, no, no. The gain in kinetic energy half mv squared. So this is important. It was having a speed of 1.3 and here it was having a speed of 2.8. Yes, speed has increased. So gain is, what is the mass? 0.030 and the speed is 2.8 square minus. For initial kinetic energy, it will be m and speed square. Initial speed was this. Plus heat is resistive force multiplied by path. And the length of the path is this. Can you see? So it will be 0.60. I hope now you can calculate it. What do you think?